section 1.4, sorry about that, I got to take my mask off. Section 1.4, part 4, we're looking at solving quadratic equations. We're going to look at the second method here in just a minute. Remember, in section 1.4, we have looked at the first method to solving quadratic equations. That was by the factoring method, or the zero factor property. Why don't we solve all quadratic equations that way? Because not all quadratics are factorable. The last two examples I put up there for you last time, neither one of those were factorable. So that's why we have to have multiple methods whenever we're solving quadratic equations. Now, before we get into the second method, because remember, there's 4 methods. We've covered one. The second method is going to involve what's called the square root property. But before I do that, I need to remind you of something from algebra. In case you have forgotten how to do this, I need to give you a quick crash course on something right quick, and that's how do we reduce square roots. So let me quickly go back over that with you for just a minute, and then we'll move on. So let me cover this up here. Start out here and look at these 3. Of course, as you know, the square root of 16 is 4, because 4 times 4 is 16. Square root of 81 is 9, because 9 times 9 is 81. Now, the part that I want to remind you of is how do we reduce a square root that's not perfect. Now, first, let me say this, because I've had students say this before. They'll say, you can't get the square root of 12. Yes, you can. It's not a whole number. But you can get the square root of 12. If you punch in square root of 12 in your calculator, it's not going to say undefined. It's not going to say error. It will give you an answer. It's going to be somewhere between 3 and 4. I know that because the square root of 9 is 3. Square root of 16 is 4. So square root of 12 is somewhere between 3 and 4. So your calculator, if it's in decimal mode, is going to be 3 point something. I don't want the decimal answer. But square root of 12 does have an answer. But what I want to do is remind you how to reduce it without writing it as a decimal. Remember, in algebra, if you can't get the square root of a number, if it is divisible by a perfect square, it will reduce. Now, what is a perfect square? It's a number that you can get the square root of, like 4, 9, 16, 25, 36, 49. Those are all perfect squares. So is 12 divisible by a perfect square? Yes, 4. So what we can do is rewrite 12 as 4 times 3. Now you say, why don't we rewrite it as 6 times 2? Because neither 6 nor 2 are perfect squares. Then you can break this into 2 radicals and then get the answer. So, square root of 12, if you reduce it, is 2 square root of 3. Now, for those of you that had for intermediate, and even if you haven't, if you get in, a lot of your calculators, particularly if you get in the right mode, a lot of calculators will do this for you. So you just need to know how to get in that mode, and every calculator is different and all those sort of things. But a lot of calculators will do this work for you. Let's do another one. Square root of 50. Square root of 50 is, think about the numbers that goes into 50. 5 times 10 is one of them. Neither one of those are perfect squares. But if you use 25 times 2, 25 is a perfect square, and the square root of 25 is 5. So another way to write square root of 50 is 5 times the square root of 2. Now, square root of 30. Square root of 30 is reduced. Now there's a bunch of numbers that go into 30. 2, 3, 5, 6, 10, 15, 30. So there's a bunch of numbers that go into 30, none of which are perfect squares. So we say the square root of 30 is reduced. It is not reducible. Let's do another one here. Square root of 48. Now the reason I always like to do square root of 48, particularly if you're doing this by hand, is there's multiple numbers that goes into 48 that's perfect squares. 4 is a perfect square and it goes into 48. But so does 16. If you use the smaller of the two perfect squares, you end up having to reduce it twice. Now once again, if you use your calculator to do it, it doesn't matter. But if you're doing this by hand, use the larger of the two, which is 16, then break it apart, and square root of 16 then is 4, square root of 3. All right, one other thing I want to remind you of is, remember, if you have a negative under a square root, that's where the I comes in, or your imaginary number comes in. 7i. Let's do one more. Square root of negative 45. I know there's going to be an I in my answer because of the negative. I can't get the square root of 45, but it's reducible. 9 and 5. So I know there's going to be an I in the answer. And then do the 45 is 9 times 5. Break it into two parts. And then the square root of 9 is 3. So that would give me 3i square root of 5. Now it would be okay if you wrote it 3 square root of 5i. Either one of these is fine. But this one is the preferred one because sometimes students, when they write it this way, they accidentally put this I up under here. And the I doesn't go up under here. It's on the outside. So to avoid that happening, we typically put it in front of the radical. So that's how you reduce radicals. Now, I reviewed that because you're going to need that in this next method that we're about to go over. So, we're about to go over, just a second here, method 2. Square root property. Square root property. All right, what I want to do first is I want to give you a note, and then after I give you a note, I will then give you the steps. So take down this note for me right quick. Here's the note. This method solves quadratic equations. This method solves quadratic equations that contains exactly two terms. That contains exactly two terms. I'm not finished with that note. So in every one of these problems we're about to do, every one of these problems is going to only have two terms in it. Exactly two terms. So none of these will have three in it. Continue the note. The two terms must be the squared term and constant term. So in every one of these problems, you're going to have the squared term. Now think about it. You have to have that or it's not quadratic. And you have to have the constant term. So if you have to have the squared term and you have to have the constant term, what's missing? The middle term, the x term. So let me give you some visuals You don't have to write these down. Let me give you some visuals of what the problems will look like when we use this method. Don't write these down. Look at these problems right here. Notice that these 4 problems all have 3 or 4 things in common. Number 1, they're all equations. They all have equal signs. Sorry, here, 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 and there. So they all have equal signs. Number 2, they're all quadratic because your variable is squared. Variable squared. Square, the variable's in here, so that squares on all of this. So variable squared, variable squared. So every one of these are quadratic equations. But there's something else that these have in common is this. In every one of these, you only have 2 terms. You have a constant term, constant, 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 constant. And you have the squared term, squared term, squared term, squared term, squared term. Because now, I didn't say it has to be just the x squared. I said it has to be a squared term. So in every one of these problems, they're quadratic equations, and in every one of these problems, you have 2 terms only, a squared term and a constant term. So in every one of these problems, the square root property would work every one of these. So in order to use the square root property, your equation can only contain the square term and constant term only. All right, so this is what it's got to look like. Now, how do we use the square root property? Take down this next note, title this next note, Steps in the Square Root Property. Here are the steps. Remember, you can pause the video. Step 1, isolate the squared term on one side and constant on the other. Step 2, take the square root of each side and introduce the plus minus symbol. Then step 3, solve for the 2 solutions. Now, I'm going to completely explain those steps as we go through the problems. All right. So, here's what we're going to do. Very similar to what I did with you a while ago. I'm going to put the problems up, and I'm going to let you copy them. And then after you copy them, I will then work the problems and go over them with you together. All right, so here we go. I think it works better after you copy it, where you can kind of sit back and watch me go over it. So here's the first problem. Pause the video now. Okay, here's the next problem. Pause the video now. Next problem. Pause the video now. Next one. Pause the video now. 2 more. Pause the video. And 1 more. Pause the video. Okay. So that's the 6 problems that I want to go over with you. So you can kind of sit back now and just watch me go over these with you together. All right, so the instructions here: solve by the square root property. Solved by the square root property. Okay, here we go. Step 1. Isolate the squared term on one side, constant on the other. It is. So the first step, let me call this example A. So the first step is okay. Step 2, take the square root of both sides. Now, let me explain to you why we do that. Let's suppose I started with the number 7. Now, let me square it. What is 7 squared? It's 49. Now, what if I turn right back around and I take the square root of it? I just get 7. What I'm wanting you to see is this. Anytime you take the square root of anything squared, it just gives you what you started with. So the reason we do this is when you take the square root of this squared, it just gets rid of that and gives you just the x. Equals. Now, square root of 25 is 5. But now I need to talk about something else. The plus or minus symbol. This is the plus minus symbol right there. Now, why plus minus symbol? Here's the reason. The square root of 25 is 5 because what is 5 times 5? It's 25. But the square root of 25 is also negative 5. Here is why. What is negative 5 times negative 5? It's also 25. So technically, when you take the square root of a number, it really has two answers, a plus and a minus answer. Now you're going to have to listen to me carefully here. You're going to end up getting a little confused. A while ago when I reviewed the radicals with you a while ago, did I put plus or minus in front of any of those? No. There are two kinds of square roots in mathematics. One is what's called a principal square root or a principal radical. A principal square root is a square root that is already on the page for you. So that's why in all those problems a while ago where we reduced square root of 48 and square root of 50, I didn't put plus or minus in front of those. Square root of 16 I said was 4. I didn't put plus or minus. The reason is the square root was already there on the page. Whenever you take the square root of both sides, that's when you're going to have to put the plus or minus every single time. Now, let me show you what help reminds me of this. What kind of equations are these? Quadratic equations. All quadratic equations have how many solutions? 2. So, if you don't put the plus or minus, you're not going to get 2 solutions. If you just put 5, that's only one answer, not 2. So in every one of these square root properties, you're going to have a plus and a minus answer. Now when you enter this answer, there is a plus minus button, I think, on that template of symbols. If you click that word more, I think there's a plus minus button down there. Or it will let you enter it just by separating it by a comma, like this. 5 and negative 5. Don't put them in parentheses though. Now, if you will go back and look at the first problem we did, no, maybe not the first problem. The second problem we did by the factoring method. We did this problem right here. And we got the exact same 2 answers. So you will run into a problem from time to time where multiple methods will work. If I had brought this 25 across and factored it, I would have got the same 2 answers. Now, why didn't I do that here? Because the instruction said solve by the square root property. But the square root property will solve problems that the factoring method won't. For instance, don't write this down because this will be the next example we look at. Just watch this. Just like x squared minus 20 equals 0. This is a quadratic equation. It has a squared term and a constant term. So the square root property will work. But the factoring method won't work on this problem because this is not the difference of 2 perfect squares. So this one is non-factorable. So I would have to solve this one by the factoring method, by the square root property if I'm going to do this. And this is the one you've already copied down. So this will take us to our next example that you've already copied, but we'll go over that in the next video.